Hello everyone, it's Benny, and in this video, we're going to finish our ALU. Now, in the last video, we added inversions for the output and for both inputs. And I did change this torch a little because it didn't actually reach from the way I had it before. So all you have to do is move it like this. Pretty simple, and I'm pretty sure you can figure it out. But, yeah. So, we finished all that. And with that, that actually concludes logic. Using this, we can do all 16 logical functions. And this also gives us most arithmetic stuff. We still need to have a way to do subtraction, but that's okay. And other than that, we just need shifting, and then our ALU will be complete. So first off, subtraction. Well, how do you do subtraction? As I discussed in my math video about how to do subtraction, which I'm not going to re-explain again, so if you want to know about that, look at that video. If I want to subtract something, so let's say 5 minus 3. Now just to make sure I'm in addition mode, I'm going to check. Now it does give me 8, so I am indeed adding. To do subtraction, we have to do two things. First, we have to invert input B. So, we already have a lever for that, so invert B. And then, what we have to do is we have to add 1. Now, I can just create a straight-up add 1 here by powering the carry-in. And this almost works. There's a couple reasons it doesn't work. One, if I have a block here, notice, it turns off that torch. We don't want that to happen. And the reason it does power that torch is because there's a dot of redstone here. The way I'm going to fix this, actually, is pretty simple. I'm going to take this, get a button, because buttons are cool, and I'd place it right here. Notice that makes it not a dot of redstone, and if I update it, it's not causing an issue anymore. So yeah, very simple, very easy solution to it. And that's one problem. The other issue is if I turn all this off, and I just invert B, you notice, if I look through here, it's going all the way to the end. And, oh, it does reach. Never mind. Issue averted. So we don't have the issue. Never mind. So that was the only issue. So now we can do subtraction by inverting B and adding 1. So yeah, okay, there we go. Problem solved. So there you go. We now have subtraction. Okay, so the next thing we need is we need a right shifter. The reason we need a right shifter and not a left shifter is because we can already do left shifting. If I want to, say, take, I don't know, this. Let's say I want to shift this left. All I have to do is take that and add it to itself. And you notice the result is the exact same thing, except shifted left. So we can already do left shifting. And you might think that might be a little bit difficult to do, but once we get memory installed and registers and stuff, this is going to be incredibly easy to do. So, we already have right shifting, we already have left shifting, now we need right shifting. So, I'm just going to do this with demultiplexers. This is a very simple design, you might have seen it before. So, yeah. Data will flow through unless the piston comes. When the piston goes forward, it's going to block off the signal at the end. And here's my second piston, which is going to have the same story. So yeah, when I power the pistons, it's going to block it off. And when it blocks it off, this one is going to go over. So, when the piston moves, power is going to go this way instead. And I want it to go over to this one. So, that's what's happening. Once the piston extends, it's going to prevent it from going here, and the signal is going to go over to the bit to the left of it, or to the right of it. I could never get my right and left straight. So, yeah. Now, all we need is that same thing for the other bit, which is pretty easy. You actually just need to do this. And you notice when this will tile, that's just going to be like this. So it's going to work out perfectly. It looks a little weird, but it's going to work out fine. Now all we need is a wire. And I found the easiest way to do the wire is just with buds. The reason you don't want to do it at the same level is because if you do it at the same level, you're going to have problems with these signals, and it's easier just to move it up and use buds and avoid all that issue. So yeah. And here we go. We have our left shifter. Yes, wait, no, right shifter. I'm just going to call it the shifter from now on because I'm going to keep making that mistake. Okay, so there we go. Now we just need to stack it. So position 1, position 2. And I'm going to stack this 3 times because there's 2 bits each. I already have 2 of them. So yeah, and that's a carry out, so we don't need to worry about that one. So there we go. That's now our ALU's output. And with that, that completes our ALU. So if I want to just do a quick test of our left shifter, just because why not? Let's add 13 plus 7. And that gets me 8, 16, and 4, 20. Yeah, that's right. And if I left shift, you notice it's left shifted and now it's become 10. And there you go. So that completes the ALU pretty much. This means there's really only one thing left to do before we're ready to say we don't need to touch this anymore, it's ready to be put in the computer. And just really quick, you should move all of these down because really no reason, I just like them better this way. So yeah, just a quick note. I mentioned in a previous video that we needed to decide whether we're going to do 8 or 16 bits. And the reason I only gave those 2 options is something I'm going to explain when we start building the actual processor. But it seemed overall people would prefer 16 bits, which is good because there's some extra considerations you need to take in, and I sort of wanted to cover those anyways, just to be thorough. But I want to give you the option, just so you can decide for yourself. So, we're going to take this, and we're going to make it 16 bits. Now, you have to be a little bit careful when you're doing this, because you don't want to stack this part right here. The reason you don't want to stack this part is because this part is actually all control logic. This is the extra bit we added for the carry-in. So we don't want to stack that. We're going to start stacking from right here. And now we're going to go over here. And again, you have to be careful because you don't want to chop off this bit at the end. That's a very important part of it, even though we haven't exactly done a lot with it yet. Whoop, nope. So this right here should be position 2. And now all we have to do is take this and actually I wonder. Okay, that didn't actually do what I thought it would. Okay, I'm actually going to stack it with invert B, I believe it is. Yeah, invert B on, because it causes more pistons to retract, and that might cause some of the errors to go away. I don't know for sure, but it might, so I'm going to try it. So, I'm going to do //stack 1. And we're just going to see what happens. And we're going to see how horrendously destroyed this thing is. And it appears... Actually, a lot of pistons seem fine. So I suppose that invert B tactic ended up working. Okay. Well, good. So now I can uninvert B. Whoa, that's control line. Wrong button. Now I can uninvert B and I can start working on this. Now, this bit right here, this is now actually important, so we need to get rid of that lever and move it over there. This also means this needs to be part of our bit shifter. So, in order to remedy all this, I'm going to take this bit and I'm going to do the same treatment we did all the other bits. Whoops. There. Now, if there's goes down. piston is right here, and there. So there's the output. And I put it one too close, didn't I? No, I didn't. Then what have I done horribly wrong? Because I know I've done something wrong. This is not right. I placed this as the wrong place. That's what I did wrong. Okay. So, of course. Yeah. Now our bit shifter is almost back in working order. Now that's connected up. And now we have all 16 bits aligned. Not necessarily connected, like right here, but they're all aligned, and interesting, they're all connected, to say the least. So now to get this working, and that has to be that. Now to get this all working, that's actually a little bit of a different story. First off, I'm going to just put repeaters on these because it's sort of just bothering me. That should reach all the way, yes. And place that button. So I'm going to get my slab back. Replace this with a half slab, and I'm going to put a repeater here. And that reaches all the way now. Okay, and that way I just have all my bits in working order. So now, I'm going to do invert B. The reason is, that makes it all 1. So now everything is 1. Now I'm going to add 1 using the carry on. Notice the second half of the bits are all on. The reason for this is, if I can actually get under here, it takes a little bit of maneuvering, but as you can see, is that actually something important, or is that just an AND gate? Okay, I think I might have just broken something important, but that's okay, now you can see it. So, whoop. See, as you can see, the power sort of cuts off here. There's an interesting little trick you can do to make this all work out. And this is why I was really glad about this new method of flood carry, because if I used the other method, you wouldn't be able to do this. If I break that, and that does break a torch, so I'm breaking even more, so I know I'm such a horrible person, place that with glowstone. Then place this with a repeater. And you notice it reaches just fine. Now the reason you need to replace this with glowstone is because otherwise it would backflow and create an infinite loop. If you have the glowstone just like this, though, it should reach all the way to the end. And yeah, there you go. Now I'm going to replace what I broke just so that I don't forget and wonder why my adder is completely destroyed. Let's see, right here I had a block. I'm going to go back and replace that. And yeah, so I can't go out that way. This is just how ridiculous this ALU is. So I'm going to break that extra block because I don't like it. Where are you? Is that what the extra block is? It would appear so. You can go away. So yeah. And that mostly fixes the problem. It also creates another problem. Because, notice, right here, there used to be a torch. There's no longer a torch there. Seriously, can I just break this piston? Thank you. So we're going to have to do some interesting maneuvering to get this to work. But actually the maneuvering you have to do is actually not that bad. Because all you have to do is move the torch from being on this block to being on this block. Actually, that won't will it? Oh, no, wait, that will, won't it? Benny needs to think about this for a moment. Okay, so I came up with a solution. But it's absolutely ridiculous. I love it. So, here's how it goes. First off, just place a torch here. Why? Anytime power is carried over, it's always going to reach this one torch. So I can just power it like that. Stats part 1. Now, this does leave a bit of a problem. What if, and I'll just break these so I don't get double blocks by accident, if I block this and this, and for some reason the carry is powered. Notice it doesn't, not the carry, the AND gate. It carries generated this bit. It doesn't turn that torch off. But I can take advantage of the fact of how I did the flood carry. Because if the block's here, it's going to send power through the block down here, under the glowstone. So what I can do, if I don't mind destroying the flood carry, is I can have power go down here, round, and into the torch. And if I power that, that turns off, and this will work in all cases. Now that's part 2. Here's part 3. We just completely destroyed our flood carry. How do we fix it? Well, actually, this is a lot simpler than you might think. What I did is I replaced these with glowstone. And here's why. I'm going to be powering 2 of these at once. And since both these are glowstone, no power will ever be able to reach this right here. Except by going down there, right? But the thing is, if it goes down there, it'd be going up anyways. The only problem is, wait, wouldn't this cause an infinite glowstone loop? Hang on, Benny needs to think about this. There might be a problem in the solution. Okay, I thought about it, and yes, it can. But that's okay, because the fix is actually pretty easy. All you have to do is you have to replace this block right here with glowstone. Which makes this solution even more ridiculous. So, I love it even more now. So now if we place a repeater there, that will power both of those carries. And notice, no infinite glowstone loop. So yeah, so now if I just let the carry through, it's working just perfectly, with the absolute most ridiculous solution in history going on so far. But, there's still a problem, because if I block this off, notice, dot of redstone powering that torch shouldn't be happening. How do we fix it? With a lever. Just like before. Well, actually last time we used a button. In fact, I will use a button, because buttons are cool. So I'm going to use a button right here, and problem solved. It's perhaps the most ridiculous solution to this of all time, but I absolutely love it. Now the only question is, did I completely destroy a bunch of essential redstone? Because that might cause a bit of a problem later. I don't see where I destroyed a bunch of essential redstone, so I'm just going to assume it didn't happen. And we'll find out that I actually did destroy a bunch of essential redstone when we test this and our program magically fails. So, that successfully extends the carry so it reaches all 16 bits. So you notice, if it's right now, it's going like that, I carry across all 16 bits, boom. So that works absolutely fine. Now really all that's left is just making sure all the other wires extend all the way. So now this doesn't reach all the way, but that's okay, because, and actually we don't need this anymore. So what we can do here now is, we can do like this, but you notice that makes it so that that doesn't reach anymore. So maybe doing like that again would be a good solution. I don't think it would, but why not? We can try. So now this should fail horrendously, but it's always worth double checking. Do you fail horrendously? Yes, you do. Okay. So I still think the easiest solution is just doing like this. That doesn't reach, does it? Nope. Nope. Okay, so I'll just think about this then. And this was actually pretty easy to solve, so you put a repeater here, and whoop, nope. Just curve the redstone around like this. There we go. Now the control line reaches all the way. So there we go. Now the logic line cuts off right about there. But that's okay, because I can get a slab again and do like this. And now it magically reaches. So yeah. That's done. Now we need to do this. And it cuts off right there, but that's fine. We can just put a repeater. And yeah. So that fixes that. We've almost solved everything. Now flood carry. We modified this, but that's okay. And it cuts off just before our super awesome flood modification, but that's okay, because now we can do this. And it magically reaches again. So we're almost done. Final one. Shift. Does this actually shift? Ah, I knew it. I knew there'd be something wrong. That's me being a derp. That's what's wrong. So, yeah. If I do like this, should reach all the way. If it doesn't, then we have a bit of a problem, don't we? Okay, so I'll repeat it here. Now just have this powered by this. And that still doesn't reach this one, but that's okay, I think. Pretty sure there's a solution to this. In fact, there is. Problem solved. Okay. So, oh, that's still not working. Why you no work? Ah, so I can't do that after all. What I can do is this. Yeah, I'll just think about this off camera so you don't have to watch me do this. So my solution was pretty simple, just put dust right there. And now shifting is working properly with some pretty ridiculous buzzing. But that's okay, because everyone loves ridiculous buzzing. And yeah. So now I'm just going to turn off all the control lines that shouldn't be on. And yeah. So with that completes our now 16-bit ALU. So that really only leaves one question. How do we do? How fast is this thing? Well, the adder in it is 2 ticks. You could say, oh no, well we extended the carry signal, but we'll worry about that in a second. So the adder is 2 ticks. The only thing logically added to this was this XNOR. This XNOR, if you ignore the piston, which we are since that's part of the control line, not part of the actual data flow, it's only 1 tick, because you can either go for the torch or you can go for the repeater. Either way, that's 1 tick. So, end result, 1 plus 2 is 3. So now, what about the shifting mechanism? Well, this doesn't add any delay at all, does it? Because power goes through, nothing happens. Power goes through, nothing happens. It's 0 ticks. So 2 plus 1 plus 0 is 3. So this is a 3-tick ALU. Now the only thing left that you might consider is this carry extension. You might say, oh, but the carry signal has to be extended. Doesn't that mean this is 4 ticks? It can mean it's 4 ticks. But I said can for a reason. There is actually an interesting little trick you can do to completely negate any carry delay. And we're going to employ that a little bit later, but I just thought you might want to know. So, this can either be 4 ticks or 3 ticks. Depends on how you do it. So I'll let you decide which way you want to do it when you actually build it. And yeah. So, this is the ALU. Hope you enjoyed. I hope you learned. And thank you. And I will see you next time.